Hi everyone, in this video I'm going to be going through the solutions to this Year 10 quiz on linear relationships and simultaneous equations written for Year 10 5.2. So let's get right into it. So in this first question, we are told that we want to rearrange the linear relationship 4x plus 2y equals negative 6 into the gradient intercept form y equals mx plus b. What this means is we want to rearrange the equation so that y is by itself. So we have it in the form y equals mx plus b. So starting off, let's just write down the equation again. 4x plus 2y equals negative 6. And so what we're looking to do is have that y by itself. So the first thing we want to do is let's move that 4x to the other side. The opposite of plus 4x is minus 4x. So we're going to subtract 4x on both sides. So we have 2y equals negative 4x minus 6. Now that we've done that, we obviously now just want to get rid of that 2. So we're going to divide everything by 2. So we have y equals negative 4x divided by 2 is negative 2x. And negative 6 divided by 2 is negative 3. And that's your answer. So now we had our equation originally in a different form, written in integrals y equals mx plus b. And from this, we can say that, well, the gradient is equal to negative 2, and the y-intercept is negative 3, which is the point of rearranging. Going into this next question, for the relationship 2x minus 5y equals negative 10, find the intercepts and then sketch the line on the Cartesian plane given below. So here we want to find the intercepts, so we'll just do them one at a time. To start us off, if I'm trying to find the x-intercept, we know that we need to make y equal 0. So to do that, we're just going to have 2x minus 5 times 0. So I'm just replacing the y with 0. And that equals negative 10. So negative 5 times 0 is just 0. So we're left with 2x equals negative 10. And then x equals negative 5. So therefore, my x-intercept, is negative 5, 0. And we'll just hold on to that for a second. Now we're just going to do the same thing with the with the y-intercept. So to find the y-intercept, we make x equals 0. So substituting that into the equation, I have 2 times 0 minus 5y equals negative 10. So 2 times 0 is obviously 0, leaving me with negative 5y equals negative 10. And then dividing both sides by negative 5, I'll get y equals 2. So therefore, I have 0, 2. So now that I have these 2 points of intersection, negative 5, 0 and 0, 2, not points of intersection, the intercepts, I can now just plot these. So I've got my y-intercept 0, 2. So I'm just going to say that that's 2 there. And my x-intercept, which is a negative 5. So I'm just going to say that's about there. And then I'm just plotting these 2 points. And I'll just draw a line going between these two like so. And that's it. I've now just gone and drawn that line by finding the 2 intercepts. So 1 mark for finding the x-intercept, 1 mark for finding the y-intercept, and then 1 mark for then sketching the line. Going into this next one, we want to sketch the following lines. So we see in this first one we have x equals 3. Whenever we have x equaling a number, we know it's just going to be a vertical line. Alright, so that means we're going to have a vertical line going through 3. So all we really need to do is draw a line here, and then let's just say that's 3. We can say like that's 1, that's 2. So therefore, at 3, it's just a vertical line. Similarly, if we have y equals a number, that means it's going to be a horizontal line. So this is just a horizontal line going through negative 4. So if I have negative 1, negative 2, negative 3, negative 4, something like that, that means I'm just going to have a horizontal line going through negative 4. And that's all there is to it. So 1 mark for each of those. Going into the next question. Consider the linear relationship graphed below. First, we want to find the gradient of the line. As we know, the gradient is rise over run. So what I want to do is choose 2 points that are on this line and then see how far up I've gone and then how far across I've gone. So looking at this, we have these 2 intercepts. So starting at negative 3, and this is negative 3, 0, I can see that if I were to, starting that left point, I've gone up. So up 6 So I'll say that my rise is equal to 6. And now that I've got that, I'm now starting at -3 and going to 0. I can say that my run is equal to 3. So now I've got my rise is 6 and my run is 3. I can say that the gradient, which is rise over run, is 6 over 3. And we don't want to just leave it as 6 over 3. We want to simplify our fractions whenever we can. So 6 over 3 is equal to 2. So just one line and 1 mark for finding the gradient to be 2. And hence we want to find the equation of the line. Well, the equation, remember, like we talked about a second ago, is y equals mx plus b, where m is the gradient and b is the y-intercept. So right off the bat, we can say that y equals 2x, because we just found that the gradient is 2. And so all we need now is our y-intercept. And just by looking at the graph, we can see that the y-intercept is at 6. So we're just going to say it's y equals 2x plus 6. And there's your answer. Continuing on, consider the 2 points on the line below. First, we want to find the midpoint between these 2 points. So the way that we find the midpoint is we find the average of the x values and find the average of the y values. So from this, if we have these 2 points, 1, 12 and 2, 3, I'm going to say that the midpoint, looking at my x values first of all, my x values are 1 and 3. So I'm going to say it's 1 plus 3. I'm going to divide it by 2. We always divide by 2. And then looking at the y values, same thing. We're going to do 12 plus 4. So 12 plus 4. And then divide that by 2. And then once we simplify that, well, 1 plus 3 is 4. And 4 divided by 2 is 2. And then 12 plus 4 is 16. Divided by 2 is 8. So we have 2, 8. And that's the midpoint. And the idea is if we were to plot this point, 2, 8, it will be right in the middle. So that's 2, 8. Looking at the gradient of the line between the 2 points. So remember, gradient, as we talked about in the last question, is rise over run. So I want to think about starting with this left point and this left point. How far down have I gone? And then how far across have I gone? So first of all, looking how far down. Nope. Not right now. Sorry about that. So looking at my y values first of all, we can see that I started at 12 and I went down to 4. So that means my rise, I've gone down 8. So my rise is going to be -8. It's negative because I'm going downwards, and that's very important to consider when we're defining the gradient. So my gradient is going to be -8, and then I need to consider my run. Well, my run is looking at the x values, so I started at 1, and I ended at 3, so my run equals 2. So now I have my rise -8, my run is 2, and as I said previously, we always want to simplify. -8 divided by 2 is -4. And lastly, I want to find the distance between these 2 points. Well, the way that we can find distance, we can either use the formula or just think about this as a right angle triangle. If we consider this as a right angle triangle, we just looked at the rise and the run. So what we're seeing here is this is 2 and this length will be 8. I know we considered in the previous question the rise to be -8, but if we were to model this with a triangle, we get rid of that negative because we can't have negative side lengths. And what we're trying to do is find this distance. So let's call that distance x. And now that we have a right angle triangle with the 2 short sides, we're going to use Pythagoras' theorem. We get x squared equals 8 squared plus 2 squared, making sure that we're squaring each of these numbers. And then as we go along with this, this will equal 64 plus 4. And then carrying on, we'll get x squared equals 68. But remember, we don't want to say that the answer is 68. We need to then square root it at the end. So we're going to get x equals the square root of 68. And then, of course, you could put that in your calculator and round to 2 decimal places or whatever. But you could also just leave it as that. Only need to round when it tells us that it needs to round to 2 decimal places or something. Going into this last page for the linear relationships questions. So we're told that a fruit picker earns $50 plus $20 per bin. So $50 plus $20 per bin of fruit packed. The picker earns E dollars for N bins picked. Write an equation of E in terms of N. That means we just want to say, create an equation that models the situation. So first of all, we're told we have E, and we're told that it's going to be $50. All right, so this person is going to earn $50 no matter what. So 50, and then we're told it's $20 per bin. And we're told that we picked N bins, so it's going to be 20 times N. So 20N. And that's all we need to do. We've now written the equation showing how we can calculate how much money this person has earned. Going on to the next question. Using this equation, complete the table of values to sketch the relationship on the number line provided for values up to 6. So what we're going to do now is we're going to complete this table of values by subbing these values in. So first of all, if I make N equals 0, I'm going to be saying E equals 50 plus 20 times 0. Well, 20 times 0 is 0, so I get E equals 50. So we'll put that number in. Now if N equaled 1 instead, so for the next thing, if I'm now making N equal 1, that's going to be 50 plus 20 times 1, and that's going to equal 70. And then continuing on with this pattern, we'll see that the next one is going to be 90, then 110, then 130, then 150, and then 170. So you'll see that each of these Y values or these E values are increasing by 20, which makes sense. We're told that we're paying $50 and then $20 per bin, where N is representing the amount of bins picked. And so now what we want to do is sketch this relationship on the number plane for values up to 6. So let's first of all look at our axes. And here, the thing along the top, the number along the top is going to be the horizontal axis. So this is going to be my N axis here. And then this is going to be my E axis. It's important that we know which axis is which. Now that we've done that, we have 1, 2, 3, 4, 5, 6. The question is just asking me to do for the first 6. And then for the vertical axis, what we don't want to do is just say 50 and then 70 and then 90. The reason why we can't do that is because if I'm saying that this is 0 and this is 50, that means that whole distance is 50. That means this needs to be 100. This needs to be 150. This needs to be 200. So we can't just change the scale halfway through. So instead what I'd suggest we do, we know that we need to get up to 170 at least. So maybe we can go up in 20s. So 20, 40, 60, 80, 100, 120, 140, 160, 180, and 200. That still will give us enough space to fill it in, but at least we also have a consistent scale. Each of these boxes are representing 20. And now we can just plot these points. So this is representing 0 and 0. So we have 0, 50, we have 1, 70, we have 2, 90, 3, 110. And you'll see, as I'm plotting these points, they are forming a straight line, as they should. These are linear relationships, and linear, as we know, means it's going to create a straight line. Now, of course, in a test, you should be using a ruler, but I'm not able to use a ruler whilst making this video. But you must be using a ruler. But we get a line looking like that. And that's it. And then lastly, we want to find the gradient of a line that is perpendicular to the line y equals 1 over 3x plus 5. So what we want to do first is let's find the gradient of this line that we actually have. So the gradient of this line, remember we just look at the number that's sitting in front of the x. The gradient for this line is 1 over 3. So therefore, the perpendicular gradient, as you may remember, is the negative reciprocal. So perpendicular gradient, remember if I had 1 over 3, a negative reciprocal means we're going to swap these numbers around and then put a minus in front of it. So the perpendicular gradient is going to be negative 3 over 1, which can just be represented as negative 3. So perpendicular gradients means you just flip them and put a negative in front of it. And if it already had a negative, then you just get rid of the negative. Anyway, so that's the end of the linear relationship section. Let's now go into the simultaneous equations section. And the first question starts off with really just more sketching. So the graph of the linear relationship y equals negative x plus 2 is shown. See that here. On the set of axes, sketch the line y equals 2x minus 4 and hence solve the equations this and this simultaneously. Simultaneously, in this case, if we sketch the two lines, the solution is going to be the point of intersection. So what that means is if we already have one of the lines, if we just sketch the other line accurately enough, we should be able to see where the lines meet, and therefore we'll be able to see what the answer is. So let's just fill in our table of values. That's probably the easiest way to sketch. So let's just put in any numbers. I can do 0, 1, 2, 3. Doesn't matter what numbers you use for the x. And now we're going to substitute it into this equation. So I might just write it to the side just so we can remember. We have y equals 2x minus 4. Now if I made x equals 0 here, I'll be saying 2 times 0, which is 0, and then minus 4, so I get negative 4. If I make x equal 1, 2 times 1 is 2, minus 4 is negative 2. If I make x equal 2, 2 times 2 is 4, minus 4 is 0. And then if I make x equal 3, 2 times 3 is 6, minus 4 is 2. So that means, now that we have my table of values, again, I can just plot these points. I have 0, negative 4. I have 1, negative 2. I have 2, 0. And I have 3, 2. And from this, I can now just sketch my line. Again, you should be using a ruler when you're doing this. And we have that line looking like that. Now that we have had our nicely drawn and neat line, we can see that the point of intersection is at 2, 0. So we can say the point of intersection is 2, 0. And that means the simultaneous solution will be x equals 2 and y equals 0. What we're meaning here is if I made x equals 2 and y equals 0, if I made x equals 2 into both of these equations, I'll get y equals 0. That's what simultaneously means. It's to find the one set of solutions for x and y that fits both of the equations. Going into question 9 now, and what the rest of this quiz is about is just going through the processes of elimination and substitution to solve simultaneous equations. So yeah, first of all, we're looking at these two equations that we want to solve simultaneously. And we see straight away that this one we've got 2x plus 5y equals 13. And the other one is y equals x minus 3. We see that y is by itself. So we use the substitution method. I talked about this in another video that I made a few weeks back. So now that we have y equals x minus 3, we can take that x minus 3 and just replace the y in the other one. So we have 2x plus 5 lots of x minus 3, and that equals 13. And now that we have that, we're going to go ahead, expand, and solve. So expanding this, we get 5x minus 15 equals 13. Adding this together, I get 7x minus 15 equals 13. 7x equals 28. X equals 4. So that's half of the solution, but we need to make sure that we substitute it back in to find the y value as well. So now that we've got that, I'm going to say that y equals 4 minus 3. And it doesn't matter which equation you sub it into, but I'm going to sub it into this one because it's going to give me the y value right away. I'll get y equals 1. And that's that. Going into the next question, we see that in this case, neither the m nor the n are by itself in either of the equations. That should immediately tell you that we're going to be using the elimination method. And remember, the elimination method starts off by writing the two equations on top of each other. So we have 2m plus 3n equals 6. And we have 4m minus 3n, and that equals 12. Now looking at these two, we can see that both the n's have a 3 in front of it. So that means we can eliminate the n. All we need to do now is decide whether we need to plus or minus. As you might remember, if the signs are different, we're going to add these two equations together. So if we're going to do 2m plus 4m, that equals 6m. 3n plus negative 3n is 0, so it just goes away, hence the name elimination method. 6 plus 12 equals 18. So now we have the equation 6m equals 18. So divide by 6 on both sides, I get m equals 3. Now that I got m equals 3, as we always must do when solving simultaneously, we're now going to substitute it in to find the value of n. So I'm going to substitute into either one of them. I'm going to just do the first one. So I have 2 times 3 plus 3n equals 6. Making sure that I'm substituting into the right letter. So if I found m equals 3, I need to sub it into m. I don't want to sub it into n. We get 6 plus 3n equals 6. Subtract both sides by 6, so I get 3n equals 0. And then 0 divided by 3 is equal to 0. So therefore my solution is m equals 3 and equals 0. Going into this next one, again we see that neither the x nor the y are by itself. So we're going to use the elimination method again. So we have 2x plus 3y equals 13. We have 3x minus 2y equals 13 as well. So looking at this, if we look at the x's, neither of these numbers are the same, and same with the y's, neither of these numbers are the same. And in fact, there's not one number that I can multiply the top row so that the numbers line up. So this is one of those cases where I'm going to have to change both of the equations to start eliminating things. So I'm looking at if I look at the x's, I note that this one is 2x and this one is 3x. Both of those numbers, 2 and 3, can multiply into 6. So what I'm going to do is I'm going to look to change this top equation so that that 2x becomes a 6x. I'm going to do that by multiplying the top by 3. So times by 3, I'm going to have 6x plus 9y equals 39. And then multiplying that bottom one as well, because I need to make that bottom one equal 6x. So I got 3x times by 2 will equal 6x as well. So I'm going to get 6x minus 4y equals 26, making sure that we multiply everything by 2. Now that we have these two, I can see that the x's now line up because they both have 6. And so now we need to decide whether we're going to add or subtract. We'll see that both of these are positive. They both have the same sign, so therefore we're going to subtract. The key to this is if the signs are the same, you subtract. If the signs are different, you add. So 6x minus 6x, it goes away. 9y minus negative 4y. You have to be careful with this. We're doing 9 minus negative 4, so that's going to equal 13y. And then 39 minus 26 equals 13, so we get y equals 1. And so now that I have y equals 1, I can now substitute this back into, again, either any of the equations. So I'm going to just do 2x plus 3, 1 equals 13, just substituting that first equation. Again, making sure that we're substituting it in for the right number. So I need to replace the y with 1. So we get 2x plus 3 equals 13. 2x equals 10. X equals 5. And so therefore, x equals 5, y equals 1. So in this question, we saw that's just elimination method again, but sometimes you need to change both of the equations so that they match up, and you are allowed to multiply by different numbers if you need to. Going into question 10, in this question, we're told that Tom is 8 years older than his sister Samantha. If the sum of their age is 36, what are their ages? So this is a question where we need to create the two equations first before we can solve them simultaneously. So our two variables, first of all, are Tom's age, so let's call that T, and Sam's age, which we're going to call S. From that, we're told that Tom is 8 years older than his sister Samantha. So that's our first piece of information. And the second piece of information is that the sum of their ages is 36. In these questions, you are always going to be given two pieces of information. If you're not given two pieces of information, there's no way you can possibly solve the question. So, first of all, let's make an equation for that first piece of information. We're told that Tom is 8 years older than his sister Samantha. That means T is equal to S plus 8. The reason for that is because, we don't want to say T plus 8 equals S. We need to say that S plus 8 equals T. Because what we're saying is, whatever Samantha's age is, which is represented by S, we just add 8 to it to get Tom's age. So, for example, if Samantha was 10, that means Tom would have to be 18. So 10 plus 8 equals 18. So we have that equation. And the other thing that we're told is the sum of their ages is 36. So T plus S equals 36. Now we've created two equations that we can solve simultaneously. And so we will substitute. We're going to use substitution method because we see that T is by itself here. So therefore, we will have just taken that S plus 8 and subbing in for that one. So we have S plus 8 plus S equals 36. So S plus S is 2S plus 8 equals 36. 2S equals 28. And then S equals 14. So now that I have S equals 14, I can substitute, which is representing Samantha's age. We're going to substitute this back into one of our equations. Again, it doesn't matter which one. So we're T equals 14 plus 8. I'm just substituting that into the first equation. And then we get T equals 22. So therefore, Tom is 22 and Samantha is 14. All right, making sure that we're answering the questions at the end. We don't want to just say S equals 14 and T equals 22. We created those letters. So we actually need to answer the question. And, you can double check to see if you're right. If we did do 22 plus 14, it does equal 36. So it fits. Last question here is we're told that tickets for a ride at a carnival were $3 for adults and $2 for children. And a total of $168 was made. 80 tickets were sold in total. So how many adults and children went on the ride? So again, what we want to do here is we want to create two simultaneous equations which we can solve. Our two variables, first of all, are the amount of adults, so let's call that A, and the amount of children, let's call that C. From that, we're told that it's $3 for adults and $2 for children, and from those prices, $168 were made. So that means we could say $3 for every adult plus $2 for every child, then made $168. So that's the first equation. And then we're also told that 80 tickets were sold in total. So that means all the adult tickets plus all the children's tickets adds up to 80. So now we have these two simultaneous equations that we can solve. Again, choosing which method that we're going to use, we see that neither A nor C are by itself. So we're just going to have to line them up for elimination method. We have 3A plus 2C equals 168. We have A plus C equals 80. And then next thing we want to do is we see that neither of these are lined up completely just yet. Let's look to eliminate the C's. The way that I can do that is multiply this bottom one by 2, so that I'll end up with 2C. So if I times this bottom one by 2, I'm not going to change the top one. 3A plus 2C equals 168. I have 2A plus 2C equals 160. Now that I've got the C's lined up, I can start to eliminate. Again, I need to decide whether I need a plus or minus. The signs are the same, so I'm going to minus. Sorry, that's not 168, there's 160. And now we're going to subtract. So 3A minus 2A is A. The C's go away, and then 168 minus 160 is 8. So So therefore, we get A equals 8 straight away. We don't even need to solve anything else. So now that we have A equals 8, we can substitute that back into any of the other equations. So therefore, I have 8 plus C equals 80. So C equals 72. And so therefore, making sure that we're always answering the question, therefore there are 8 adults and 72 children. That's that. And again, we can double check our answers. If we do 8 plus 72, that does equal 80. And if we do 3 times 8 and 2 times 72, that will also equal 168. So it satisfies both the equations. Anyway, that's the end of the quiz and therefore the end of the video. Hopefully it's been useful. And if you have any more questions about linear relationships or simultaneous equations, be sure to ask. Hope this has been helpful and thanks for watching.